Greetings, math friends. We are going to talk about trigonometric functions, but to arrive at that location, I want to start with a first-degree polynomial. This type of structure is an algebraic structure that you should be familiar with since probably before you studied Algebra 1. So we're going to start here to motivate an understanding of the way the trigonometric functions are defined and behave. So the first thing that we're going to do is we're going to talk about the inverse function. So we denote the inverse function with a -1. And what we want in this case is that for every output from this function, it becomes the input for this function, and the output from this function would be the input that we had put into here. So in other words, this function is going to undo whatever this function does. So we can run through this process and solve for that if we wanted to. So I can say that I'm defining the inverse of this function to be this function. So let's test this. First of all, we're going to just test it at a point. Let's put in 1 here. So if I do f of 1, we have 3 times 1 plus 8, and that is going to give me 11. So now I want to take this 11 and put it as the input here. So I want 11 here, and my anticipation is that the result here is going to be 1 because that was the input here. So we have 11 minus 8 divided by 3. 11 minus 8 is 3, so we have 3 over 3, which is 1, so that checks. Now, to actually check this properly, we want this to be both a left and right inverse, which is a little more technical. And to test this, we would actually compose these two functions, and that's really beyond the scope of what I want to talk about here. But I have demonstrated in just one point that I can take the output of this, put it in here, and then the output of this is the input here. So this is doing what we want it to do. This function will be the inverse of this function, so it undoes it. All right, so that's what we have there. So let's talk about reciprocal. So this was inverse. So what is a reciprocal? Well, when we talk about fractions, if we start with this fraction here, 2/3, the reciprocal of this would be 3/2. We essentially flip it over. Well, what is this really doing? If these are inverses and we multiply them together, they give us 1, which is the multiplicative identity. So that's an important characteristic to look for. All right, these are multiplicative inverses, all right? But we've already defined the inverse function as being the function that undoes the other function. So this is what we're going to call a reciprocal. So the reciprocal, we want to be the flipped upside down fraction. So if I start out with f of x here, then I want something that I multiply by that to give me 1. So this is 1 over f of x, which is just taking this as a fraction. If we call this f of x over 1, we flip it upside down, it's 1 over f of x. If we multiply these two together, they do give me 1. So they are multiplicative inverses, which give me the multiplicative identity. So how do I create this type of thing, whatever it is? Well, I can just simply take whatever this was and put it in the denominator. So I can call this 1 over 3x plus 8. And then I'm going to have to designate this as some kind of thing. Hopefully, it is a function. All right, so what am I going to call this? So we don't really have an official designation for this. I'm going to call it f sub r of x, and this is going to be my reciprocal function. Notice that this thing and this thing are not equal, all right? So this definitely does something different than this. All right, so if I plug in 11 to this function here, I'm going to get 1 over 41, because I have 3 times 11 is 33 plus 8 is 41. So the output here is 1 over 41. The output up here was 1. Definitely different outputs. So this is a completely different function that I have here. Also, the domain of this is different from the domains of these two up here. If we take a look back up here, the domain of this is all real numbers and the range is all real numbers. The domain of this function is all real numbers and the range is all real numbers. But the domain of this is not all real numbers. At some point, there is an x that we can choose, which will send the denominator to 0, which means that would be undefined at that point. This ends up actually being a discrete function, and these two are continuous functions. So very different in what each of these three functions do as compared to each other. Now, there is a relationship to each other, right? Because we started with f of x, and we built these other two functions based off of what we know of this, all right? But they're doing different things, and the graphs are very different. So now that we have talked through that set of ideas, we're going to start to apply this to trigonometry. All right, we've got this set up so that we can see a comparison. This was our linear example. We started with the first degree polynomial. We created its inverse and its reciprocal. And now we're going to look at the sine function as our example, and then look at its inverse and reciprocal. So over here, every stage, we had a change that occurred over here. We're going to see a change occur over here. And these look very different because we aren't defining these in the same way. There is a geometric process that's going on behind the scenes here. And then we're going to give it a name. So the name of the function is sine. And T is just for trigonometry or trigonometric function. These are just to show the parallel with here. But we have our first function here is going to be sine. To do its inverse, we're going to call this arc sine. All right. And the domain and range are different here than it is here. So that's a slight difference here. These two have the same domain and range. These are going to have different domains and ranges. All right. And then when we go down to here, we can see sine is in here. We don't see sine in here. This is the cosecant that we have here. So a very different name convention here from the first two. We've called this thing cosecant here. This is exactly what we had over here. This is going to be 1 over sine x, and then we gave it a special name. So there is the tie-in with the name sine here. And these things, there are some meanings behind what is the way that they're named. Sine is derived from Latin. It's the same word that you get sinus, like you have sinus pressure in your head. So that's the relationship there. There is an alternate notation here. So on your calculators, if you're using a calculator, you'll see sine with a little -1 over top of it on the button. So this -1 is this -1 here, the -1 that we use here as a representation for the inverse. So it is properly called the arc sign, but you could also see a notation where you just see the sign with a -1 floating over here. And they put the exponent on the word sign and not on the input value here. So that's something else to notice. And then when we do squares and things like that, they also, the common notation is to put that exponent above the name of the function and not over near the input, the x or the theta or whatever symbol you have for the input of that function. All right, so I wrote all of these as functions of x, just like we had in our first degree, but it's also very common to have a Greek letter here because the input for this function is an angle and the output is a ratio of sides of a triangle. That's what those functions actually do. Like I said, there is a geometric process kind of under the hood here with these functions. So a lot of times you'll see Greek letters here because by tradition we use Greek letters when we talk about angle measures. But you may not always see that. X is perfectly fine to use as a variable here. So I want to go ahead and give you a chart that shows all of the three basic commonly taught trigonometric functions with their inverses and their reciprocals. This is a nice chart to have as a reference as you work through problems. Keep it handy and refer to it often until you get an understanding now of what these things are and do. I hope this has been helpful in helping you understand some of the basic ways that we have named the trigonometric functions, and maybe hopefully giving you a little bit of an insight on how some of the things that we've done in an early algebra phase tie into what we're doing now with the naming conventions and the way that these functions operate and interrelate. Cheerful calculations.